Today we're going to be talking about divisibility. There are two definitions, vocabulary words for this section. The first one is divisible. What does it mean if a number is divisible? It means that it is capable of being divided by another number without a remainder. Okay, so it divides evenly. We know that 6 can be divided by 2 to give us 3, and 6 can be divided by 3 to give us 2. So that means 6 is divisible by 2 and 3. All right. Now the word factors kind of goes right along with that. Factors are the numbers that we can multiply together to get another number. So since 6 is divisible by 2 and 3, we know that 2 and 3 are factors of 6. Okay? So you should have your divisibility rules. They're over on the blue counter. Go get them. You're going to glue these into your spiral so you don't have to write them down. But if you want to take additional notes, put examples or whatever next to the information, then you can do that. So I'm going to go through each rule one at a time. All right, a number is divisible by 2 if the last digit is even, meaning is the last digit 0, 2, 4, 6, or 8. Okay, so we're going to see if these three numbers are divisible by 2. So the number 204, the last digit is a 4. That's an even number, so yes, that's divisible by 2, meaning I can divide 204 by 2, and I will not have a remainder. The number 1099, it ends in a 9. 9 is not even, so this is not divisible by 2. 3,456 ends in a 6. The 6 is even, so this is divisible by 2. That's a pretty easy one. You just have to remember 0, 2, 4, 6, and 8. A number is divisible by 3 if the sum of the digits is divisible by 3. So we have to do a couple things here. First, we have to find the sum of the digits, meaning we have to add the digits up. And then we need to ask ourselves, is that divisible by 3? Okay, so numbers that are divisible by 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. We could keep on going. But I'm going to show you a trick that if you feel like you have to keep on going, you can actually just keep adding your digits over and over and over again. All right, so this first one, 45. First, we add the digits. 4 plus 5 equals 9. 9 is divisible by 3, so 45 is divisible by 3. Okay, 78, we add 7 plus 8. This equals 15. Okay, 15, is that divisible by 3? Now let's say you're not sure. Guess what? You can do this too. You can say 1 plus 5. That equals 6. I know 6 is divisible by 3, so I know that works, okay? See how I kept adding these digits? All right, and the last one, we have 9 plus 1. That equals 10. I know 9 is divisible by 3 and 12 is divisible by 3. 10 is not. Right? This one is super cool. I love the rule of 3. All right, a number is divisible by 4 if the last two digits form a number that is divisible by 4. So we're going to look at the last two digits, and we're going to see if it's divisible by 4. So 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. All of those are divisible by 4. And if we need to go higher, we can. Okay, so the last two digits of 122 is the number 22. Is that on my list? Nope, I have 20 and I have 24, but not 22. So that is not divisible by 4. 424. Yes, 24 is divisible by 4. So the whole number 424 is divisible by 4. And then the last one. The last two digits are 0 and 8. That's just the number 8. Can 8 be divided by 4? Yes, it can. So 108 can be divided by 4. A number is divisible by 5 if the last digit is 0 or 5. Last digit, 0 or 5. Super easy. 23,675, it ends in a 5, it's divisible by 5. 9,880 ends in a 0, divisible by 5. 258 ends in an 8. That's not 0 or 5, so it is not divisible by 5. If we were to divide it by 5, there would be a remainder. A number is divisible by 6 if the number is divisible by both 2 and 3. So I have to obey my rule for 2's, which, remember, it ends in an even number, and my rule for 3's, which is the sum of digits is divisible by 3. Okay, so I like to check for 2's first. Let's see if it's even. 245 ends in a 5. That is not an even number, so automatically 245 is out. It can't be divided by 6. 90 ends in a 0. Okay, so that's like a half of a check mark. Okay, because that means it can be divided by 2. And then we have to check, are the sum of the digits divisible by 3? So 90 is 9 plus 0, which equals 9. Can 9 be divided by 3? Yes, it can. So that means 90 can be divided by 6. Last one, 646. We end in a 6, so it works for 2. Let's see if it works for 3. 6 plus 4 plus 6. Okay, 6 plus 4 is 10. 10 plus 6 is 16. I'm not sure if that's right, so let's keep going. We're going to do 1 plus 6. That equals 7. Can 7 be divided by 3? No. Okay, so 646 is a no for the number 6. That one's a little tricky. You have to check 2 things. And divisible by 9. Numbers divisible by 9 if the sum of the digits is divisible by 9. So this is like the rule for 3. We're going to add the digits and see if it's divisible by 9. 9, 18, 27. I'm just going to stop there because I can keep adding the digits till I get to one of these. Okay, 214, I do 2 plus 1 plus 4. 2 plus 1 is 3. 3 plus 4 is 7. Cannot be divided by 9, so 214 is not divisible by 9. 387, 3 plus 8 plus 7. 3 plus 8 is 11. 11 plus 7 is 18. There it is. 18 can be divided by 9, so 387 is divisible by 9. And 1 plus 6 plus 2 for 162. 1 plus 6 is 7. 7 plus 2 is 9. 9 can be divided by 9, so 162 can be divided by 9. In the last rule, a number is divisible by 10 if the last digit is 0. Super easy. 2,350 ends in a 0. Check. 765, it ends in 5. That means it's divisible by 5, but not divisible by 10. 3,986, that means it's not divisible by 10. It ends in a 6. Make sure you get your 2 vocabulary words written down for this, and any examples you want to put from this you can.